Hello, my name is Joe Shaw. I am an incubation engineer in the incubation engineering department, looking specifically at application performance management and monitoring and how we can bring that into the entire GitLab DevOps platform. This is my weekly update video. Here's my APM specific issue for this week. So what have I been doing? My current update, I've further documented the Datadog endpoints for the agent that we're looking at using for APM. So I've documented the initial metrics for the metrics endpoint, which is used to capture time series data and some basic events. And this is the first one we're looking to tackle as part of our first iteration to get this data in and store it. I'll just show you here. So this is the first environment variable or bit of config that this part of the agent supports. There are lots of other parts like process and log monitoring, things like that we aren't going to analyze at the moment until we need to. So documenting this, I've started putting this documentation in this issue. We've got the sort of requests that we expect, like a validation request there, and links to parts of the documentation. There are some potentially slightly, unusual non-documented parts of the agent here. So there's this intake endpoint that we need to have a look at a bit more, where there are a couple of requests here, for example, that sends through a lot of metadata about the host that it's running on. So it will send through information about the hardware specs, the operating system, host names, install method, all sorts of useful stuff that we could use for auditing. We probably aren't looking to capture this. What we might do for the time being is just log this information out so we can check logs and see what's going on, but we probably won't save this initially unless we actually need to refer back to this. And really, if we need this for end users to be able to sort of make sense of what agents are being used, for example. So there's an initial one there. It shows you, for example, what other processes are running in this environment. And then a second one gives you a lot more information. I've yet to really break this down. It seems to give sort of container error states and things like that. And then we get a check run endpoint, which is events about service checks that the agent is performing. So for example, here, we're blocking external traffic when we're testing this agent. So this NTP in sync check is failing with this somewhat cryptic status code, which I believe means critical in this case, because it goes 0, 1, 2, 3. So I think 0 is okay, 1 is warning, 2 is error, 3 is critical. And other checks, for example, here, like the actual agent itself is okay, and so on and so forth. So that might be useful, but again, we won't look to intake that straight away. What we want to focus on is the series data initially. It's where we actually have things like system metrics, and I've shown you this in a previous video, so I won't go into that at this point. So that's that bit of documentation, and that's going to feed into an initial iteration. Where's that? It's not there. So this initial iteration will be looking at how we implement a gateway service to do authentication against GitLab with access tokens, handle that series endpoint and the storage as well. So another thing that we've done this week is create an initial system design. So this is the issue here. And you can find all this linked in my weekly video issue, which will also be linked in the bottom of this video as well. So this is a fairly typical architecture for something like this. We have agents here. focusing on Datadog, but we think, other compatible agents, potential API clients. So another compatible agent might be, say, OpenTelemetry, gateway service that implements that API initially. We talked for a little while about using Kafka, but because GitLab already uses Google's PubSub service for the SaaS only side of the business, in particular handling logs and pushing those into Elastic at the moment, we're going to reuse PubSub because there's a lot of knowledge about that already within the teams. So here we're going to ingest that data. We're still evaluating ClickHouse, but it's looking like a strong potential candidate for the actual data store here. So I'll get onto that in a second. And in terms of being able to visualize and interact with this data, we're looking at putting Grafana on top of it with a query proxy as its own database, and it allowing us to embed that in GitLab itself. Some notes that I've put in here, I don't think I need to go into any particular details at the moment. And we've had a good conversation with people in infrastructure, for example, about how we might go about setting this up as its own service. It's got quite nice service boundaries, so we don't have to host it in the same environment as GitLab.com. We can have it in a separate Google Cloud project and obviously a separate Kubernetes cluster, for example. So that will make it easier to isolate it and understand the costs around running this service. So that's that. The other thing I'm looking at right now is the schema evaluation for ClickHouse. I started this last week as well. So we're looking at, I've expanded upon this a bit, put a few more links in, a bit more of an introduction. I'm in the process of documenting some other time series databases, because what we want to do initially, because we're looking at time series for this very first iteration, is just compare and contrast a few of the other examples. I'm going to use this time series, I'll drag the link over here, time series benchmark suite, which I think was created by InfluxDB initially, and now it's been sort of taken up by TimescaleDB to do a bunch of comparisons between time series specific databases. See ClickHouse is in here, and TimescaleDB and a few others. So I don't want to benchmark against all of them, but what I want to do is compare a potential more generic schema that we might use against the ClickHouse schema that this benchmark uses, because this is a very sort of hard-coded, very specific schema for certain series data. So like one schema for CPU, one schema for memory, for example. We don't really want to do that. So I'm going to see if we can get a sort of equivalent or a decent enough performance with a more generic schema. I will also be comparing those results against some of the other competitors based on whether we think they're applicable or not. So I've been looking in here, for example, if I should preview this, I'm editing this at the moment, looking at, comparing these databases. So we want databases with replication, high query flexibility, a decent amount of maturity, and ideally a multi-model. So it's not just time series, but we can put other data in there, so we can work with logs. We can, when we get there, work with traces. So only a few of those come out of that. So I'll be doing a comparison with a few of those to make sure that we're going in the right direction. Obviously, we don't have time to compare every single database on the market, but it's a bit of due diligence to back up what we've decided to do. So I'll be continuing that the rest of today and next week probably. And we've forked the time series database project so we can make relevant changes there. Any fixes, any issues we find, we'll contribute back to the upstream project. So yeah, that's it for now. And you can see up next, continue with that and continue to refine the infrastructure stuff. So that's it for now. Thank you for watching, and I'll see you next week.